Hi, I'm Irvin, founder of JSMapreduce. In this video, we'll be learning about the JSMapreduce cloud service for big data processing. Many students and data scientists are learning about the MapReduce programming paradigm, which was pioneered by Google for its internal massive scale data analytics. What MapReduce does is to enable a programmer to take a huge amount of data, say many terabytes or petabytes of data, which would be too voluminous to process on a single machine, and to process it in parallel on many machines. This video assumes you have a basic understanding of MapReduce. If you don't know what MapReduce is, please read up on it online and return to this video. I got started with distributed programming during my time at Google, where I wrote many map reductions for advertising analytics. The MapReduce programs we wrote would execute in a Google data center, processing many terabytes of ad impression data. They would then build statistical models to optimize future ad campaigns. One of the concepts we had in those days was a debugger for MapReduce, which would give insight into the execution of a distributed process running in parallel on multiple machines far away from the developer. This concept of debuggability, single-stepping, and transparency for MapReduce stuck with me, and after I left Google, I combined these ideas into JSMapreduce as a service to make MapReduce immediately approachable for beginners, debuggable, and single-steppable, all while still maintaining the industrial strength capability and scaling of MapReduce. We believe that JSMapreduce is the most transparent, debuggable, and manageable MapReduce infrastructure available. As you may recall, creating a MapReduce application requires you to write two functions, the mapper and reducer functions. Once ready for production, the mappers and reducers are deployed on hundreds or thousands of machines, and the mappers are hooked up to a large source of input data records. The mappers each process one data record at a time and generate intermediate key value pairs that are of interest to the developer. Those key value pairs are sorted by the infrastructure and passed to the reducers, which sum or otherwise reduce the data as indicated by the developer. Many large-scale compute problems can be made manageable by this MapReduce paradigm. For example, the task of processing the contents of all web pages on the internet, something that Google does routinely. Google has its own data centers with lots of machines to execute MapReduce. Most other data scientists use a cloud service, which means that they temporarily rent the requisite machines in a data center owned by a cloud service provider, such as Amazon Web Services, Google, or Microsoft Azure. Now let's talk about JSMapreduce. As the name suggests, JSMapreduce lets you write your MapReduce, your mapper and reducer code, in JavaScript, but it also supports Python, with other language support coming soon. Most MapReduce infrastructures, like Hadoop, require you to download and install a client software package for your development. They then require complex setup on a cloud service. Monitoring and debugging the MapReduce is difficult, requiring you to dig through log files and such. Finally, obtaining the output of your job is initially a manual process. We feel that all this setup and maintenance is a distraction from what you really want to be doing, which is learning and extracting valuable analytics from your data. So with JSMapreduce, we've eliminated all that setup. With JSMapreduce, you never have to install or deploy anything. You never have to deal directly with the cloud service. Your code is storable in JSMapreduce for easy deployment and collaboration. Everything is always transparent and easily inspectable. You can start testing a simple MapReduce literally within seconds. Furthermore, while testing, you can single-step the map reduction, one mapper or reducer call at a time. This single-stepping is great for debugging, but also for initially learning about the mechanics of MapReduce. Students love the ability to single-step and examine the input and output of each mapper or reducer call. The easiest way to experiment is to look at the samples on the main JSMapreduce screen. The first example is in JavaScript with a small set of text records. By convention, the records are new line delimited, so the mapper will receive one line of input at a time. In this simple example, the lines of text are lines of a poem, and the job is to count up all the unique words. In a real-world big data application, the input might be all the text on the internet, which would require many machines. But for this sample, we can just execute on a single machine. This is how map reductions are commonly built. You first develop on a small sample set of data and execute locally. Then you deploy to a cloud service to process the entire record set on many machines. JSMapreduce makes this transition easy. With a sample selected, we can single-step through the mapper phase, followed by the reducer phase. See how the input and output of each mapper and reducer step are shown in the status and debug screen. You can single-step or click Run to run through the entire job. The output then appears in the output window at bottom right. There, you've just executed a MapReduce. You can modify the sample code and input data right there in the browser to experiment. You can also save your code within the service. Since this sample was so tiny, the job was runnable on a single machine. We say it ran on one shard. For a real big data application, over terabytes or petabytes of input data, your job will run on hundreds or thousands of shards. That is, it will run on many machines that are provided seamlessly by our cloud service. Let's talk about input data for a second. In the first example, the input data was lines of text that were simply pasted into the browser. This is a great way to get started, but what about large data sets? A large source of data might be delivered via Amazon Cloud Storage in an S3 bucket on Amazon Web Services. JSMapreduce also has a novel input data scheme that we call the kernel function. Often, the input data for your job is large, but it can be generated by a small program. Sample 2 shows an example of this. The input is a representation of every possible poker hand, which is large but is generated by this small kernel function. So instead of providing a large data set of input data literally, you can opt to provide a kernel function that generates the input data. Continuing with sample 2 for a minute, this sample demonstrates a real piece of data analytics. The job takes the input data, which is all possible poker hands, and counts how many hands of each type there are, how many straights and flushes and such. To accomplish this, the mapper takes each poker hand and determines its type. It emits a key value pair indicating the hand type as the key, with a value of 1 as the count. In the reduce phase, each reducer sums the counts for hands of each type. The status and progress of the map reduction is presented on screen, where you can monitor or stop at any time. If there was an error, either in your code or with the service, a detailed error message would be shown to you. The result of the sample 2 job is the count of all poker hands of each type. Since we're still developing on a small scale, the output is delivered right back to the browser in the output area at lower right. Samples 3 and 4 are written in Python. Sample 3 is a very small job with literal text as input. As always, the input records are new line delimited, unlike sample 1, which had plain text as input. Sample 3's input is JSON structured data. JSON is a popular way to structure text data and is easily processable by both JavaScript and Python mappers. Sample 4 is just the sample 2 poker analytics job again, but in Python instead of JavaScript. Finally, let's talk about running a real-world big data application with large input running on many shards. JSMapreduce lets you transition seamlessly from its uniquely simple testing environment to its industrial-strength scaled cloud infrastructure. The mapper and reducer code that you tested in your browser are automatically migrated and executed on many machines in a data center of our cloud service, so you never need to configure any virtual machines manually. To run a cloud job, you must first purchase credits on the service. Credits are $1 each, so credits is just dollars. You should have saved your mapper and reducer code in the service. Now, click Run in Cloud. This dialog lets you launch a scaled MapReduce on many machines in the cloud service. But it's still simple. Select the input source. Select your saved mapper and reducer function that you want to deploy. Now select the output location, which could be an Amazon S3 bucket. But if the reduced output data is small, it can simply be delivered back to your browser. Many large jobs reduce their final output to a small size that can simply be delivered back to your browser. At bottom, you can indicate the number of mapper and reducer machines for your job. It's normally best to leave these blank and let the service determine the ideal number of machines. And click Run to start the job. As when testing, you can monitor the state and progress of your job right on the main screen. What's more, the charges incurred by the job are updated every few seconds, so you know precisely how much it's costing you. And you can stop the job anytime you like. When the job completes, you'll see a final status and the cost of the job. Note that billing is rounded up to the next dollar to keep things simple. One word about collaboration. JSMapreduce allows you to link accounts with fellow students, instructors, or coworkers. Linked accounts can see and deploy each other's code. This is great for collaboration in a shared learning or working environment. JSMapreduce is a simple-to-use yet powerful big data analytics service for academics and industrial data scientists. The smooth transition from local development to scaling in the cloud is a hallmark of JSMapreduce. It's great for development. It's also great for debugging. When there's a problem on a shard of your scaled cloud job, the problem shard can be migrated back to your local development environment, where it can again be single-stepped and debugged. We believe these are unique features of our service that will optimize your productivity as a data scientist. This concludes our introduction to JSMapreduce. We hope you'll find JSMapreduce useful for learning about distributed programming and in your data science career.